In an industry that is constantly evolving, it is essential to use all the tools that technology provides us to streamline decision-making, conduct tests, and maintain increasingly agile processes. The digital twins, which are digital replicas of an asset in a virtual environment, enable us to achieve those objectives. These solutions allow us to mimic functionalities, characteristics, and behaviors of an object, system, or process, all within a digital environment, facilitating informed decision-making. At NTTDATA, we have the capability to create intelligent digital twins that are fully connected, modular by design, highly scalable, driven by user requirements, always with the operator in the loop. The development of digital twins involves working under a generic architecture that aims towards the construction of services. However, there is no standard way to build digital twins. There is no established method for implementation, so how do we approach this? For the development of this type of solution, our primary focus is on assembling a top-tier, certified, and highly experienced multidisciplinary team. Then we work on having an asset that allows us to represent the solution physically. Having a physical asset, we can begin to develop a digital twin. How? By building use cases. First, we define the problem. Then we construct the capabilities and services that will be part of the digital twin. And finally, we represent them in our asset. The microfactory simulates a manufacturing process with real components used in Industry 4.0, such as a Siemens S7 1500 PLC utilizing the OPC UA communication protocol or a TXT controller, which facilitates communication via the MQTT protocol. This manufacturing process consists of 7 stations, each with a defined purpose, emphasizing a SCARA robot vacuum gripper, responsible for pick and place the material to the different stations of the process, a high bay warehouse for storing raw material for future processing, a station simulating an industrial furnace and polishing of the manufacturing piece, a conveyor belt that discriminates by product type and facilitates transportation to the dispatch station, and finally, an environmental telemetry station providing measurements of temperature, pressure, humidity, air quality, and luminosity.
It's worth highlighting that the microfactory is equipped with sensors at each of the mentioned stations, which facilitates the implementation of a variety of real-world use cases, such as condition monitoring, predictive maintenance, augmented reality, to mention a few.
To determine the capabilities of the digital twin, we developed an application that generates the digital twin's capabilities periodic table, allowing us to determine the features of our digital twin.
This allows us to build a series of services, such as remote monitoring, machine learning of the asset, interactive 3D photorealistic visualization, and live bidirectional synchronization.
The development and implementation of digital twins and their different functionalities enable us to create different use cases. This type of asset and solution is applicable to any industry and becomes an essential ally to achieving a higher level of efficiency and productivity.
Thanks to the NTTDATA Global Innovation Center, multiple microfactories located around the world are also interconnected in a supply chain-like network. And as showcased by Digital Twin Consortium, the global authority in digital twins, our approach can be leveraged to foster collaboration within an open innovation ecosystem.